Now the stage is yours.
Thank you, Stephanie. So I just put my counter here. So I really enjoyed the body language of our friends of EcoInfo doing like that or like that. It's not easy to speak to you like that. So I use a body language maybe that was proposed by Birgit in a mail about a month ago. So I'll use a cap. And this is body language. This is a cap for emotion and opinions maybe. And to say that I'm really happy to be able to talk to you physically. The first time I come to this conference physically. And I really tremble to speak in front of so many leading researchers in the area. So I take out this hat. And now, I'm going to talk about estimating the footprint of oil and, sorry, not oil and gas, but the ICT. And we first looked at a technical point, which was avoiding double counting. And then we saw we could apply this to a question like evaluating the global footprint of ICT. So if we look at the framework of methods available for doing that work, we have basically, here we start with physical measures there, and then traditionally for ICT, we have an intermediate step, which is LCA, and then we flow all the data the way to, then we go through LCA, and then the data flows to a work which is weighted inventories, and then we have the figure. Now, what we wanted to look at is we know that there's this second path available on the left-hand side, go through national statistics that are available on a yearly basis for all the countries, and then go to another type of method, which is input-output analysis. So we compare our results to reference studies, and for instance, the reference studies of Malmodin and Lunden that are present in this room. That's why I tremble. And these May original studies, in-depth studies, I would say, in fact, they all follow, if I understand well, the weighted inventory approach that relies in turn on LCA. And there was a very interesting meta-study. I think one of the authors is here, Mrs. Widdicks, and it's the study in 2021 of Freitag et al. And they say that, in fact, they claim that these studies relying on weighted inventory are subject to an underestimation bias due to a technical problem, which is LCA cutoff. And they give an estimation for this underestimation. So what can input analysis help in doing in this problem? And a classical way of looking at IOA, input-output analysis, is big matrices, lots of numbers and matrices, vectors. And this is a little bit tedious, so let's look at it in a graphical view, through a graphical view. And it's much easier. So on the left-hand side here, we have a group of sectors. Typically, we worked on the OECD classification sectors into 44 sectors. And so you have a bunch of 44 sectors. They all interact between themselves, and they exchange commercial goods, of course. And they are all driven by the final demand, which is here on the right-hand side. And so the final demand of people like you and me, they issue requests for productions. And so let's look at final demand for products I. Let's picture it as a PC. So we need a certain quantity of PCs. We quantify it by a letter, a quantity DI. And so to produce these PCs, we need the industry I here, producing PCs, to produce a production of PCs, and which is larger than DI, because they have to produce PCs for the whole value chain of producing PCs. And by the way, it's not a value chain starting with a start and an end, it's a value network. So everybody's contributing to this value production. And input-output is a classical way of, so it's used generally to estimate the footprint of the final demand, and it's generally used for estimating the footprint of countries. And so we did this on the world scale using the data from OECD, and we arrived with this figure for the footprint of the final demand. Now, what about the industry? So it can be used, and it was foreseen 10 years ago, and thank you for the anonymous review who pointed out this to me 10 years ago, to estimate the production footprint of an economic sector, such as, well, it's well defined. The problem is that ICT, in this classification of 44 sectors, is a group of 4 sectors. And the classification is not good enough, so if you take those 4 sectors, it overstates ICT. So the problem we were trying to tackle was calculating the footprint of a group of 4 sectors. So IOA can be used to do that, and we made a calculation. We arrived to this figure. Now let's look at the numbers. So sorry, I had other hats to wear, but I'm too carried away. So this is a hat for applied reasoning. So you see here you have the 4 sectors that are relevant for ICT in the OECD classification. The first one is computers, electronic, optical products. And so if you add up the direct emissions here, you end up with a number here, which is, you can add it up, it's additive. You can do the same with final footprint here. You can add it up and you have this figure. But you can't do the same with production footprint. You cannot add up the figures for all the separate 4 sectors. So you have to retrieve the the double counting. And so we do this. And we find a double counting ratio about 7% in this case. And so we retrieve it and we have this figure, which is, by the way, too important if you compare it to the reference studies. So we looked into what was in these the 4 sectors, and they were overstating ICT, so it was a larger scope than ICT, and we had to remove electronic components and remove a bunch of things. So in removing, we had a big approximation in doing this work. That's why the result of the removing is rather an interval here. Now, we remove it, we remove satellite networks, we remove a bunch of things, but we have to do something that IOA cannot do, which is estimate the use phase footprint for everything in the economic system that is not ICT sector. And so we looked at the paper from Malmodin and Lunden, and I figured out that maybe this figure was correct, so I add up this figure. And I obtained finally this range, which I compare to the range proposed by Freytag et al. And I find, oh, it's compatible. But it's rather in the high end of the range. And I think my time is over, so the conclusions are do we have yet another indicator or a family of indicators There are still lots of approximations in this work. That's why I need to collaborate with people that can help me reduce these approximations. And it is best used if we can combine it with LCA work for the use phase. But the good thing about this is the data is open source. You all can use it. And the other thing is the method is simple. It's fully described in the paper. You can replicate these calculations and find all the bugs I made while I was doing them. So thank you for your attention.